This is RD Sharma solution, class 12, chapter 16, tangents and normals, exercises 16.2. Find the equation of the tangent to the curve. So this is a curve which is parallel to this line. So this kind of questions we have already attempted, but since it is an under root question, so we'll try to attempt it. We have 4x minus 2y plus 5. Let us equate it with y equals to mx plus c. So take y on one side and other things on the other side. So you have 2y equals 4x plus 5. Just divide it by 2. So just divide by 2. So you get 2x plus 5 by 2. You see this 2 is m. M is the slope. So this slope will come from where? From the dy by dx. That is, dy by dx is essentially the tangent slope. So we'll differentiate it. And you have to differentiate this under root 3x minus 2. And you know under root is nothing but power half. So if you write power half, 3x minus 2 to the power half minus 1, it will be there. Half minus 1 is negative half. Differentiation of 3x minus 2 will be 3. What do you get? 3 by 2 as a constant, and this 3x minus 2, negative half will go downstairs. It will be 3x minus 2 under root. Now you have to equate it with m. M is what? 2 here. Now you can find out the value of x from here. It's just simple algebra, and you just have to take the things on the ground, that is the denominator, to the right hand side, and just square it. So what do you get? This is 3 is a 9, 4 4 is a 16, 3x minus 2. So this, when you solve it, you'll get x as 41 by 48. You can just do it by yourself also. 9 by 16 plus 2, and whatever is coming divided by 3. Now in order to find y, just put this x in here in the original equation. So what do you get as y? It is 3 by 4. We have x and y here. X is 41 by 48 and y is 3 by 4. So this is x and y. Now you can formulate the equation y minus y1 is equal to mx minus x1. So y minus 3 by 4 is equal to m. That is 2 x minus this is 41 by 48. Again, I would really request you that this is now simple algebra. You can just rearrange this equation, and let me write the final equation here. It will be 48x minus 24y minus 23 is equal to 0. This is the final equation. Now let me show you the reference here, because those who are willing to solve by themselves or write somewhere, this is the way they should write. Find the equation of the tangent to the curve, this one, which is parallel to the line, this one. So as we are on the 17th question, we have already attempted questions like this in the earlier 16 questions. So I will just go past this question, and I will leave you with the reference solution so that you can try it by yourself. So we have to prove there is one equation here, there is another equation there. So we have a straight line which is x by a plus y by 2 equals 2, and this line is touching at point AB to this curve. The concept will remain same. There are no numbers here. That is the only thing, and there are certain powers being given. So it is a simple differentiation problem, basically, if I can say that, with the line trigonometry or line equation in picture. So we will try to use this a and b, that is the point, and the equation x by a and y by b to the raise n equals 2. So we'll differentiate this equation, put the point a and b, and then we'll try to come to this straight line as x by a plus y by b equals 2. So eventually first and third thing which is given, we'll try to use to get the middle one, which is x by a plus y by b equals 2. Alright, so I'll just do it for now. This is nx by a to the power n minus 1 plus, this is simple differentiation here. So we have, because x by a differentiation will also be done, so it will be 1 by a. Then we have y by b, so n y by b to the power n minus 1. Y by b differentiation will be 1 by b only, and since we are differentiating with respect to x, we'll get dy by dx, and on the right it is 2 constant, so it will be 0. So when you rearrange it, see, there is a plus sign in between, so there will be negative definitely on the right hand side. The n by a, x by a, n minus 1 will go on the right hand side, and n by b, y by b, n minus 1, raise n minus 1 will go in the denominator. So n by a, x by a to the power n minus 1 here, to the power n minus 1 in the numerator, and denominator we have n by b. As I said, negative will definitely come because there is a plus sign on the left hand side. N by b, y by b to the power n minus 1. So now just see, n gets cancelled, b goes up, a goes down. X by a and y by b can be combined because the powers are same. The power is n minus 1. So x by a by y by b, this b by y it is. So we have bx by ay, and this one is raise n minus 1. Now this is what? You don't have to go beyond that or solving it, because a and b points are already given. Just replace x by a, y by b. minus b by a, b into a. I'm replacing a and b in place of x and y. So what do you get? What a and b gets cancelled. 1 raised to anything will be 1 only. So minus b by a will remain. So this is your dy by dx. This is the slope of the equation. Now we have the slope, we have the points a and b. So we can formulate an equation. Y minus y1 equals mx minus x1. a1, x1, y1 is a and b. The dy by dx is minus b by a. So just use it. So this is the actual equation which we formed, and we'll try to achieve that middle equation from here. So let's just cross multiply. ay minus ba equals minus bx plus ab, and this goes here, this goes here. So bx plus ay is equal to twice of ab. Now divide everything by ab here, and ab here also. So bb gets cancelled, you get x by a gets cancelled, you get y by b. Here ab gets cancelled, you get 2. So what do you think? Is that equal to the middle one? Absolutely, yes. So this was the whole scenario of this question. Now let me show you how you're going to go about it. The logic I explained to you, but this is how you're going to write. Find the equation of the tangent to the curve. X equals sine 3t, y is equal to cos 2t at t equals to pi by 4. We have done it for pi by 4, we have done it for pi by 2. So let us attempt it again. Dx by dt is cos 3t, means differentiation is 3 cos 3t, because sine 3t is cos 3t, 3t differentiation is 3. dy by dt is cos theta is minus sine theta, and you have to differentiate 2t also, so 2 comes in front. So what is dy by dx? So just divide dy by dt to dx by dt. So you get dy by dx here. So I'm just dividing it here, minus 2 sine 2t divided by 3 cos 3t, and at t equals to pi by 4. Pi by 4 is nothing but 45 degree, and 2 into 45 degree is 90 degree. 3 into 45 degree is 135 degree. You can also write it as 3 into 45 degree through 135 degree. Okay, so what we are going to do here is we'll just use this 3 pi by 4. So 2 dy by dx is negative 2 sine into twice t. So sine 0 is 0, sine pi by 2 is 1. So minus 2 into sine 2t will be 1, of course. 3 into cos 3t. So you have cos 3t. So you have to use this 3 pi by 4 here. The 3 pi by 4 is nothing but pi minus pi by 4. So cos pi minus pi by 4, cos 180 minus theta is a negative cos pi by 4. So this is 1 by root 2 only. Cos 45 degree is 1 by root 2. So minus 3, 1 by root 2 here. So this is going to be minus gets cancelled. 2 root 2 divided by 3. So this is your dy by dx. Okay. Now what will be the value of x? What is the value of y? It is already given in the question. And we have dy by dx also. So this is x equals a sine 3t. Y is cos 2t. T replace it by pi by 4. In both the cases, sine 3 into pi by 4. Here, sine, as I said, it will be sine 135 degrees, sine pi minus 45 degree, you can call it. And you know, add sugar to coffee, sine theta in this range is positive. So it will be negative, non-negative, it will be 1 by root 2, sine 45 degrees, 1 by root 2. What about cos twice t? So 2 into pi by 4 is cos pi by 2, you get a 0. So you got the point here, and when you have the point, you can find out the equation, because you already have the dy by dx, that is the slope of the line. So y minus y1 equals to mx minus x1. x1 y1 is your 1 by root 2 and 0. The dy by dx m is 2 root 2 by 3. You just need to rearrange it and you'll get the equation. So this is 2 root 2. This is root 2 minus x. You have 3 root 2 here. Y. Now just multiply it here, and you'll see that the final equation is going to be 2 root 2x minus 3y minus 2 is equal to 0. Okay, so let me show you the reference. This is how you're going to go about it. This is how you're going to write. At what points will be the tangents to the curve y equals to x cube minus 15x square plus 36 minus 21 will be parallel to the x-axis. So m is tan theta. You are finding the tan theta is the positive direction or anti-clockwise direction angle with the x-axis. Since it is given that it is parallel to x-axis, it is x-axis only. So the angle is 0. So the slope or tan theta is 0 only. So dy by dx, we'll find out and equate it to 0. Dy by dx, I'm directly finding it out. 6x squared, 15 into 2 is 30, 30x, this will be 36, 21 will be 0. And this is going to be equal to 0. Dy by dx, as I said, it is parallel to x-axis. Parallel to x-axis means the angle with the x-axis is 0, so slope is 0. Equate it with 0, which is our slope. Now divide everything by 6 here. This whole equation we are trying to solve here. Divide everything by 6. So x square minus 5x plus 6 equals 0. X square minus 2x minus 3x plus 6 equals 0. X take common, x minus 2 minus 3 take common, x minus 2 equals 0. You have x minus 3 into x minus 2 equals to 0, because this is how you're going to get the roots of this equation. One time you're going to get 2, one time you're going to get 3. Now we have x and y. So if we have x, we can find out the y from the original equation, which is 2x cubed minus 15x squared plus 36 minus 21. So I'm replacing this x as 2 in the case number 1. And in the case number 2, we are going to replace x equals to 3 in the original equation. So I hope you'll be able to do this stuff, because this is simply simple algebra, and I'm quite sure that you are able to solve it, because I'm just showing it to you. And at x equals to 2, there will be certain value of y. At x equals to 3, there will be certain value of y. So you know that since dy by dx is already 0, you already presume that when you will make the equation, the right hand side is going to be 0, because the slope is 0. So why we get 7 for 2? Here we get y equals, because if you place x equals to 3, there will be definitely some value for y, and this x and y are just the 2 points, because the question is also asking about at what points will be the tangents to the curve. So there will be multiple tangents here. So 3 and 6 at the point. Let us make the equation. Y minus y1 equals to m. M is what? 0. dy by dx is 0. Whatever you put on the right hand side doesn't matter for us, but we have to complete it. And here also y minus 6 equals to m, which is 0, and x minus 3. This goes 0, this goes 0. Y will be equal to 7 here. Y will be equal to 6 here. So you have two equations, and it has to be there because the tangent is parallel to x-axis. Y equal to 7 and y equal to 6. They are definitely lines which are parallel to x-axis because they don't have any content of x. This is y equal to 7, y equal to 6. Anything which is parallel to x-axis is going to be parallel to these tangents only. And that also confirms, you can say reaffirms the solution we did. Okay, so let me show you the reference here which I explained. This is how you're going to go about it. Now this question is somewhat different. I'll give you one solution and I'll show you another solution. So there are two ways to do it, because this question, the straightforward thing is where we find dy by dx. Differentiation will do. Dy by dx, what is this going to be? 6x minus 2y dy by dx, and this is going to be equal to 0. We are differentiating this equation actually. So 2y dy by dx is going to be equal to 6x. This 2 gets cancelled, you get 3. So dy by dx is nothing but 3x by y. Now 3x by y, we already have a value 4 by 3 and 0 given in the question. Now when you put it here, you will find out this y is going to be 0. That is the main say roadblock here. Because when I'll show you the another solution, you'll see that has been catered here. But I'll show you that if you put originally the equation 3 into 4 by 3 divided by 0, you get a 0 in the denominator, which is infinite, which is undefined. So anything which is undefined, we don't go forward. But since we have done a question like this already, slope 0 is nothing but a line which is parallel to the y-axis, right? Parallel to x-axis, the slope is 0. Parallel to y-axis, slope is infinite. That is, we don't know it, but still we have 0. 0 has some meaning. So I'm going along with this because dy by dx we got as 4 by 0, which is most of the mathematicians, they don't like it. They don't, abide with it, but we'll still solve it. I'm taking 4 by 3 and 0 as x1 and y1. dy by dx is 4 by 0, or rather 1 by 0 I'm writing, but it is 4 by 0. So when you multiply this, x minus 4 by 3 will be there, x is equal to 4 by 3. And this reaffirms that a line, equation of the tangent, which passes through this point, whose dy by dx is essentially equal to this 3 into x by y, which is actually infinite. So you have to have a line which is x equals to 4 by 3, and this is nothing but the line which is parallel to y-axis. Okay, so this is the one thought of thinking about this question. But most of the solution provided by different websites and different mathematicians, I'll show you that solution right now. So this is the reference solution which I am providing you. Since we don't want to deal with this 0 in the denominator, we'll do what? We'll take h and k point, which is essentially equal to x and y only. Then we'll try to find out the value of x and y for this 4 by 3 and 0, putting this 3h by k, because previously we placed it as 3x by y only. So we'll get x and y, which is right now in this question we are calling it as h and k. And h and k you'll get a proper value here. There will be no 0, there will be no dy by dx, which is frustrating because anything which is divided by 0 is always not acceptable in mathematics. So this is the solution you can follow. This is one of the solution. The other solution I gave you. This is all about this exercise. Thank you so much and take care of yourself.